up with a talk about the OSGi Residential Specification Release 6 by Mr. Kai Hackbart from Process and Mr. Andreas Kraft from Deutsche Telekom. You're both two long-timers in the OSGi Alliance, and you're the co-chairs of the Residential Expert Group. So, please.
Okay. Yeah, hello everybody. Just after the talk after lunch, always a difficult one, especially when it comes to a bit more heady topic than usual. So no demos here, but we want to give you an overview about the latest residential specification we worked for the last 2.5 years in the Residential Expert Group with a lot of experts from Orange, from Telecom Italia, from NTT, and many Process and many other companies as well. And first, we want to give you a short overview about kind of recap what's the problem, why there is a residential expert group at all, or was a residential expert group at all, and then the role of OSGi in the residential market, and then we want to give you some in-depth details about the specifications we have in this second release of the residential expert group. The problem, or the ecosystem structure, not the problem, is that it is really diverse. So there are lots of standards, there are lots of technologies in the market. So you have wired protocols, you have wireless protocols, there you have proprietary standardized protocols by SDOs or by other industry bodies. You have some which are IP-based, some which are nearly IP-based, and those that are IP-based are perhaps even IPv6, IPv4. So a lot of integration that has been done first on the upper layer of the OSI model, so to say, but also on the technology level, actually on the physical level, how to integrate those. The problem here is that actually it's they all make sense. So all of these field buses and field bus technologies have their meaning. So for example, you have this MBus, which is a wireless protocol, which was developed, I think, in the early 90s, which was really picked up because it was cheap and really reliable for metering inside homes. Then you have others like EnOcean, which is a rather new field bus technology, which uses energy harvesting. So competing with existing ones like Zigbee and Z-Wave, you obviously know. And then there's IP-based protocol, which are a long time in the market, like UPnP, which most of you know from standards like DNA, so media conversion here, but they are also moving into the direction for controlling to the IoT, controlling your home, or this kind of, but this is IP-based. This diversity of standards, there are a lot of bodies here. So we have, of course, the OSGi Alliance, which originally came from the service gateway in the home, and there are other consortia like AGI or the Broadband Forum, which try to integrate those standards which are already there, or at least make them accessible or manageable in this regard. And they have IEEE, and so the interesting thing that we managed over the last, I don't know, 6-7 years, basically to talk and to agree with all of these bodies here. You see on the screen for the use cases, to have an alignment here and to work together and to, well, basically be friendly and ask them if they make some changes in their protocol, or please let us know, and to coordinate this. This was especially important, and this next slide. The role of OSGi in this ecosystem is basically everywhere. So we started in the beginning, 15 years ago, in the home gateway. So there's a smart home, the connected home was a market here, and let's see where this went. But the problem was actually it was too expensive. It was really that the technology was not there. So basically Java in an embedded device was, from a business point of view, well, basically out of the question. It was too expensive to have a full-fledged PC just in a router. So then, of course, we had the cycle for mobile market and the vehicle, but then actually everything was really taken off on the enterprise level. And this is actually where this was still very successful, of course, like IBM WebSphere and other cloud service platforms based on OSGi nowadays. And but yeah, a couple of years ago, this actually came back. People remember that actually the solutions which are there are basically the same in the residential market as well as in enterprise, because it's modular problems, because of all the diversity of standards in the field buses you already saw, that no connected home is the same. They're all different technologies. Even in the same house, you have different installations, either the privately owned flat or even rented flats. It's because of diversity of the use cases. So different devices, different technology, different applications and business cases for elderly people as well, or for young people, they are completely different. And here, OSGi to the rescue. The hardware was inexpensive enough, fine enough, and performant enough, actually, that you can integrate this in router or in separate devices for a reasonable price. And also the field bus technology also moved on. So they were much maturer here. As I said, a new technology like EnOcean came up for energy harvesting. So no new wires in your home. Some interesting, promising to end customers. And so yeah, a couple of years we started to look at the residential market again, and did a lot of work here. And together with the other consortia you saw on the previous slide, like the Home Gateway Initiative, which really defined use cases, business cases, and really specification, how to integrate this. Also doing tests here, test cases for the integration to help to choose vendors and actually technologies. Here, this was basically a transparent thing. In the middle, you see the cloud. At the time, a couple of years ago, there was really no cloud. Well, there was, of course, there was a cloud, but this was actually known as back-end servers. And so the management system for a telco, it's actually bread and butter business. You know how to manage a big, large-scale system, and actually you know that these kind of protocols, like for example OMADM in the mobile market or TR69, the whole TR69 suite for router technology, is actually there. It's really stable. It's a bit big maybe nowadays. It's a bit complicated if you look at RESTful system, but actually it really makes sense when it comes to batch and automated operation for the remote management. And so on the first release, this was published around 3.5 years ago in 2012. We focused mainly on the management part. This is not the management part on enterprise system, but really on the remote management for systems which are perhaps not always available. So they might be disconnected, they might be not available at all. And as I said before, it's not under the administration, under the management of a real back-end server management, where you really have full control over what's there, what's not, because of the diversity again of the applications you can find here. We had to make some changes here. For example, we had some, not really changes, but actually we talked with the BBF people, broadband forum people at the time, and actually they also participated in person. The same people worked on the standards in the broadband forum, also in the residential expert group, and actually the standards you find in the broadband forum, if you dare to have a look there, then they're basically really aligned here. So TR69 for the management of bundles, of services, of configurations on a OSGi framework, and then the TR 157 Amendment 3, that's the software module guidelines. This is basically something we developed basically in the OSGi Alliance, but also brought and liaised, so to say, to the broadband forum is how to manage software modules and what is here. And for this also we had the DMT admin, which is the DMT stands for Device Management Tree. It's from the OMADM. It's an original standard here. Which was, it's rather useful to manage basically trees. And this we basically completely redesigned here to have it very flexible. And actually last year we had a workshop here in Germany where some people from a project of Kai use it for a completely different system, complete application. It is a mass massive parallel system for analysis of medical data, and they, for the separate nodes, they are now able to put them into this management tree and be able to do it. It's very flexible, very powerful. It's a hard to read specification, I have to say, but it's really it's really powerful when it comes to mass management here, and you get all the flexibility here. But for the new one, I think that's why you're here. We released this just a couple of months ago. That's the specification. So on the first one, we really focused on the management aspects of the specification. On the second one, we are now focusing on the connectivity for various technologies. So we started, just to give you an overview, and Kai will go into details of the separate specifications, but it's basically the EnOcean and the USB category and serial device specification, which deals with the low-level connectivity here. So basically adding something to the usual device access that you already have for a long, long time in the OSGi specification, in order to give you some enhanced or some add-on information, especially for USB. It's very interesting because, well, even if you plug in a USB stick, you have no idea what it actually is in the end. Then Network Information Service deals with some, basically puts a layer on some non-portable enhancements of Java VMs, especially when it comes to IP network interfaces. You have no idea whether this goes up, whether it's a loopback interface, so some always proprietary extensions, but basically to put this under one specification, so basically as the integrator has to be responsible. This is done here, and resource monitoring and device abstraction layer. I think you heard a lot this week, but I think that Kai will go into detail here as well. And yeah, give over to Kai. So just give you some.
Just a minute. All right. So, hello everybody. I'm trying to, let's say, give you a short overview of the specs we have done. Let's start with this here, so that I. Okay, it's good. So, okay, EnOcean Device Service Specification. This was driven by Orange. André Boutaro is sitting here if you have questions later on. And basically what was done there is, André was showing this earlier, is like, you know, defining a base driver for OSGi, for EnOcean. And that is, let's say, compliant to the device access specification. So you have the possibility to discover and control EnOcean devices in form of OSGi services, and OSGi services can also be exported as EnOcean devices, and we do provide support for event handling. So if you are familiar with EnOcean, you may know that the EnOcean Alliance defines a lot of EEPs, device profiles, and we do not have support for them. There are different reasons for this. One is, you know, it's like a huge document. I mean, it's like impossible to support all of them, I would say. And they're also from different domains, not necessarily only smart home. And the other thing is there are also legal issues with this, because there's intellectual property that, let's say, we cannot just reuse and republish. Yeah. So just so you understand, you know, why it is structured like it is. The specification has a big diagram. It was a bit too complex, so I didn't want to, you know, put it here. But as Andrea said, you can download the specification today. It's available, and basically review the specification. You know, start your own implementation of them if you want to. That's completely fine. Next.
The last point, the interesting point here is actually, that OSGi services can be exported as EnOcean services. So if you want to basically have a simulation or export them as EnOcean service, then it's possible as well.
And what we have to say actually is that we followed the principle that we you know, did in the UPnP device service specification. So
it's transparent in both directions.
Exactly. So then we have the USB device service specification. The reason why we have worked on this is home gateways today, they may have support for 1 or 2 wireless protocols on board, but some providers see the need to be extendable, and this can be done in form of USB dongles, a ZigBee USB dongle, a Bluetooth USB dongle. And the problem that, let's say, we are facing in OSGi is that if you stick in the USB dongle, the OSGi environment can't tell what it is. I mean, it knows it's a USB device because it has a base driver, but it's not able to recognize, is it a ZigBee support, or is it a ZigBee dongle, or is it a Bluetooth dongle? And this we actually did here. So we basically defined a service so that we can get additional information out of the USB dongle, and then can deploy the appropriate refining driver. And yeah, so it's realized as an OSGi service, obviously. Right? Serial device service specification, also a pain in the ass, if you want to say. If you have a home gateway and you connect to be it a USB dongle, ZigBee, Z-Wave controller, whatever, you talk to it usually via the serial port. And the problem associated with it that there are different libraries. There's javax.com, there's RxTX, and I think Java 8 already has now also a new serial port interface. And so it's very fragmented. And yeah, so what we were trying to do to have a common abstraction and basically to have a standardized way to talk to devices via the serial port. Network Interface Information Service. The issue here, this one and the previous one were driven by NTT, the Japanese telecom provider, that you have a home gateway, you have IPv4 at home, and your IP address, for example, may change over time. And Java today does not provide you the ability to get a notification or to actually recognize these changes in the network interface, be it the IP address, the MAC address, the subnet mask, whatever. And so what we were trying to do is basically A, to provide the means to recognize this, and B, to send notifications to interested services, yeah, so that they can appropriately change.
And especially in some environment, in hybrid environments where you have more than one public IP address, for example, or something like that, or you have wireless LAN which is switched on and switched off, for example, by the user in the home because of reason for energy saving, for example, then this is a come and go interface. And you have no idea, for example, if you want to bind an HTTP server at the address, that it's actually there, what the address is. And this is basically the service to get you some information about that in a OSGi portable way.
Exactly. All right. Resource monitoring. When we started working on the specification, we still called it resource management. We changed it to resource monitoring because there is today no standardized way in Java to monitor resources and to, let's say, manage them in an OSGi environment. So this was driven by Orange again, and Process already had some support for this in let's say, in our framework, in the MBS framework. And the idea is to be able to monitor the resource usage from bundles. This can be very granular, like one bundle or a set of bundles, an application. And so we can monitor 5 resource types. Right now, CPU, memory, disk storage, threads, and sockets. And we can add additional resource types can be added. and the whole thing is queryable. Sorry, it's a difficult word somehow. And obviously there's an eventing mechanism, yeah? So, I mean, you want to get a warning or an error message in case, in case a specific predefined threshold, you know, is not meeting anymore, is not met anymore. So, yeah, here you see just an example, yeah, CPU consumption over time. And so there is a threshold defined for, you know, when you have a normal usage, when you know, you want to maybe put out a warning, and when you definitely need to do something, yeah. And as I said, this is just the monitoring, yeah. We do not do the management, so we do not perform any management operations, yeah. Reason for this is that we had a couple of fights, you know, how accurate is this, for example, yeah. So I mean, if you have a couple of bundles, how do you know that this bundle is responsible for the resource consumption, yeah? And so we had a mechanism that let's say we define a context, yeah? So saying that if, you know, bundle A calls bundle B, yeah? The resource context, or the context belongs to bundle A. So it's a best effort approach, yeah? And the management, there are also then, you know, different ways of dealing with it. And we basically decided for now not to approach this. But it's definitely a topic that we were discussing again in the IoT expert group, so it may come at a later point in time.
And it is interesting that, as Kai already said, is how resource management is actually more on a business level than actually on the technical level. Of course, it has a technical aspect, like how do you actually know the CPU consumption or the memory consumption, but actually it's the business part of it is actually if you have one bundle which provides a lot of service for many other bundles, because it's a basic thing. Of course, it uses many resources in the framework, but it is responsible and it's even be at fault from using those resources. No, it's not. So that's actually, it cannot be decided automatically. It really needs to be part of the overall configuration and integration then of this bundle or of this policy here.
Exactly. I mean, it's all about reliability, yeah, making sure you have a reliable environment, and B, I mean. Especially companies like Deutsche Telekom that, you know, ship home gateways, they also have to care about service level agreements, right? So.
And the other aspect is, of course, these are more technical things like CPU, memory consumption, and so on. But you can actually use this service specification for all kind of resources, where you have, for example, if you have a resource providing to other bundles as well. I don't know. External storage, for example, I don't know, your personal Dropbox service here, then of course it is a resource, and external space is a resource, and actually this can be managed here as well as sockets and any other kind of things which are interesting here for your business or for your implementation. Yeah.
All right. Device abstraction layer. You want to do this one again, or because you mentioned this yesterday? I can do it, so all right. So, device abstraction layer. So the device abstraction layer is driven by Processed. My colleague Evgeny is the author of the spec. So, the way this actually happened is that we at Processed already, you know, had like a device abstraction layer in our framework, proprietary, and this was basically the starting point because, I mean. OSGi is really about building an ecosystem, yeah. So you want to, you know, make it as easy as possible to, you know, attract developers, yeah. And this is what the device abstraction layer is all about, yeah. So first of all, basic functions are, you know, discovery, notification mechanism when you add or remove devices, appliances. You want to be able to control and query, you know. State values of the appliances. You need an eventing mechanism, and you want to be able to manage those appliances. And this can, you know, go as deep as, for example, a firmware upgrade. Yeah. Nothing happens. All right. So let's say this is how it should not be done, right? So basically, you have drivers for the different technologies. You have apps, and it's a big mix of who is using what driver in order to talk to those devices. And so this can get out of control. You have dependencies that you cannot manage anymore in a certain point in time. And so this is basically how we do not want to do that. And the device abstraction layer, the idea is that we want to create one API that is applicable to all relevant communication protocols. We don't really specify the communication protocols here. And it should support a generic device data model. We want to be able to do operations on the devices. We want to make sure that we have a fine-grained access and access control based on user and application permissions. Yeah, and we basically use here also a lot of flexibility that is already provided, by the OSGi specifications. And as I said, it's about a notification mechanism when there is a state change for the device. A change in the device data model, or when you perform an operation. And this is basically how it looks like. So we have drivers for ZigBee Z-Wave devices, and then we have adapters that basically are the bridge to the device abstraction layer, and the devices that are they are registered as an OSGi service and accessible as an OSGi service, and the app basically uses one single interface to talk or to manage a device. And as I said, the whole point is really to get an ecosystem going, and so what we do not have right now is basically an ontology. Yeah, so we don't have, let's say, a standardized set of devices, but we tried to specify some, let's call it, basic functions, yeah, that you can start with, because what is a device abstraction, or what use is a device abstraction layer if you cannot use it? Yeah, so we tried to think of a couple of very generic usable functions like Boolean control, Boolean sensor. So basically they have only two states. Yeah, multi-level control, multi-level sensor. So something like a dimmer would be multi-level control, because you have maybe like 100 different states and additional functionality. And we have some other functions, and they have different types. So you can, for example, say a Boolean control is a light switch, for example. So we already define a couple of types, so that this is, let's say, usable. And yeah, so these implementations are available, as org OSGi service DAL.function, and they can be reused in a specific domain. So they're not really, they are generic usable. Yeah. It can be extended in case the functionality is missing, or it can also be replaced with a specific ontology for a specific domain. And Andrea specifically works on something that deals with it. The HGI, the Home Gateway Initiative, defines this smart device template. So basically how you describe the profile of a device, and the result basically can be fed, for example, into the device abstraction layer.
Yeah. And there's also ongoing activity on a really global level for a global organization, 1M2M. I don't know who was here in the talk from André Botaro just before lunch. This is a global organization of organizations. So, for example, ETSI, ATI, NZ, and so on are members of that. And they are currently defining an ontology to define domain-specific ontologies. So it's lot of meta definitions here, but it's basically one meaning to define what is a light switch, what is a Boolean actor, what is a temperature sensor, and this is not only for the home, but of course for all kinds of basically M2M markets, be it connected cars, smart city, industry, whatever. And this is really interesting because this is one of the next things we would like to support here on the next level of the abstraction, is to automatically reasoning by means of ontology and semantic reasoning is what does it actually is. So it's even if you have no idea what the TV set is from your application, but if you want to switch everything off, which is not really important, then this is easy to do because it's something which can be switched off just automatically by semantic reasoning here. And this is something we are currently working on, and we are also going to support next stage in OSGi, I think.
Right. All right.
Just one remark for the abstraction. Can you go just slide back? The interesting thing here is, in comparison to the other one, where everybody is actually using and integrating everything, is that you have a lot of responsibility in the application because somehow you have to know about ZigBee, how ZigBee is actually using this, or how Z-Wave is actually using this, and want to have one application supporting N technologies, then it has to have N stacks. And so the decoupling which is done here is also from the technology point, from the responsibility point of view, and also a bit from the legal point of view, because you don't have to have a contract with the ZigBee or with Z-Wave or other technologies. You have to pay fees for using this, or license fees, because the integrator for the abstraction layer is actually responsible to do so, and actually it takes a lot of burden if you want to bring a product to the mass market, actually from the application developer here. And I think this is also very important, that the application developer is much freer and has to care less about all the dumb legal stuff. He has to care if you want to bring something into the market.
Okay, so then the last slide, conclusions. So the residential expert group delivered 2 specifications for smart home, or 2 specification releases is a better term here. So because the IoT expert group has been founded recently, we are currently not quite sure whether or not to continue in the residential expert group, because I mean, they're overlapping topics, yeah? So, I mean, IoT or the smart home is basically part of IoT, and the rec specifications are already applicable also to other IoT domains, yeah? So this is, a little bit still in discussion, and there's, one time we think, we should stop here, and then there are other times where we think, maybe it's better to continue, and not yet decided. I think what is key here is really that we, really try to collaborate with other standard bodies, yeah, especially HGI, Broadband Forum, but we also work on establishing new liaisons, for example, with the Industrial Internet Consortium. This has already been done. And we are also trying to set up something with one M2M. According to my, let's say, the way I see the development of smart home, and also with respect to the role of OSGi, I would say that the residential expert group specifications really helped the adoption. So today, especially telcos, they have plans for, deploying smart home systems, and they really, have requirements for OSGi, yeah? So also for specific specifications of OSGi, including their configuration. The fact that HGI, for example, developed a specification specifically defining requirements for home gateways, for modular software architectures and home gateways, and how they have to be, configured, etc., was very helpful. And we have, I think, right now lots of examples where OSGi is being used. Deutsche Telekom with the KiwiCon system. We have AT&T in the US with the Digital Life system, TTNet. There are probably even more that I can't. France Telecom. So you see, it's it's really playing a role in a global market. Yeah. All right. You have some last words?
Okay, got time
to
to stop?
Oh, okay.
Questions?
Time flies.
I didn't realize.
A couple of minutes left for questions. Everything is crystal clear.
Okay.
Okay, if there are no questions, I'd like
So,
to...
as I said, the guys that were writing the specification, Andre left in between, but he will be around. Evgeny is here, so talk to
Nicola is
us.
here.
And Nicola, right? Nicola, right? I didn't see you, so we're here. All right, thanks a lot.
Okay.